Hey, how's everybody going? How you doing? This fine. Of course, I always do that. Let's try this again. Whoa. Okay. Hey, how's everyone doing this morning? I guess evening for y'all in the U.S. How was your weekend? Hope everything went well. Just getting started out here in Japan. Had my coffee. I think I'm about ready to go. Well, today we're going to be covering implementing a hit reaction and things such as hit stun and potentially hit stop if we get around to it. Um, so we'll have to add a reaction system. If you're here for our initial streams, we discussed the architecture of this game, and things are basically split up into these systems that are staged, as you can see in our architecture chart here. The reactant system is at the bottom here. The reason for that is we're going to want to have reactions override things such as action transitions in the combat system. So other things we'll have to do is we'll have to add hit stun, which is effectively going to be a timer indicating how long you're stuck in that reaction, or character is stuck in that reaction. Okay. And one thing we have to make sure is the action timeline doesn't actually determine when returning to idle occurs. We don't want, by accident, maybe a designer going through and mistiming an animation or something and causing hit stun to be shorter than it should be or longer. If we get around to it, we'll do like hit stop, because that's very important for 2D style action games. Okay, just to get started, let's go ahead and look at our current common states we had set up in the game. Okay, we hit standing, walking, attacking, crouching. We don't have a reaction yet. Okay. Let's just start by roughing out our reaction. We're just going to call it reaction for now. In the future, we're going to have many different types of reactions. Let's just call this one a reaction. And we're not going to be afraid to throw out old code in the future, right? Okay. So one thing we want to do is set up transitioning into a reaction when a character is hit. We'll do that within the reaction system. Okay. So we just copied this this state for from the attack state. So we don't need stuff like this. This transition stuff code right here. We're going to have something in here potentially returning back to idle. In the future, we'll probably move that out into the reaction system itself. Or we'll do it today. We'll see. We'll see which way I think it's going to end up being the better way. And I just realized this should be on end. Yeah, and we'll do that here as well. Okay. So yeah, we don't want this kind of logic. We want something that looks more like if context dot reaction. So we're going to have to add a reaction component as well for storing things like hit stun and hit stop. Okay. So yeah, we can have reaction component, and let's say like frames elapse. So we could have like hit stun as a timer that starts from something high, right? And as long as it's greater than or equal to 0, something like that, or greater than 0. As long as it's greater than 0, we don't return to idle. But if it's less than or equal to 0, for example, because we're starting at a high value going down to 0, then we'll do that kind of logic of returning to standing or whatever. Now we don't have that code yet for a reaction component, so we'll have to do that today. Did we put that on our planning list? Yeah. Yeah, we need a reaction system and a reaction component. So for now, let's go ahead and just add a reaction component first. So our components are in, well, yeah, we have components in here. So let's just go ahead and add a reaction component. This will store, for now, just our hit stun. Let's be I32. Okay. And I want to see what's our like a boilerplate for setting up the components. Just looking through our quick search here. So we need to do something for a combat state. We'll have to reference it for our context. So let's see. Okay, there's that boilerplate there. What else do we have? This is for incrementing. We'll have to do something like this in our reaction system. And this is just updating this stuff. Okay, here's some more boilerplate we need to set up. We need to set up a set of reaction components here. Again, at some point, we're going to do a stream kind of abstracting a lot of this work. Instead of having all this boilerplate we have to do each time when we add a component. Though we'll probably have a fixed number of components. We're not going to be adding them a lot. But it would be nice to like kind of generalize it. Okay. And we have to initialize. Again, this is the other kind of boilerplate we have, right? We need to initialize everything for each of our active characters. Oops, I don't want to do that. I'm going to copy paste this. Okay, so with that boilerplate, I think we've taken care of most of the boilerplate stuff here. Okay. And all this stuff's for the state machine. Okay, great. Okay. So, let's save all in this. Control KS, okay. Whoa, didn't want to be here. Okay, next step, we created the component for it. Now what we'll have to do is, we need to implement the transition as well, right? I forgot to put that down, so let's write down that real quick. Let's go ahead and mark that off. We've done that. Okay. Now when a character gets hit, they need a transition into a reaction. That's going to be handled within the reaction system itself. So I'm going to put that as like a subtask of that. Okay. So we'll just go through and add our new reaction system. Currently, let's go through where we have, what do we have our code set up as? We have, do we have a systems folder? We have a collision. No, we don't have a, let's go ahead and add a new file here. Call it reaction system. Zig. Let's just kind of copy some of the stuff we have in our collision system at the top. I don't know if we need all this, but we'll go ahead and do that. And we'll have to go through, what else do we need? Probably need most of these things, a component, game state, math. I don't know if we need math for now, but let's go through here. We should have in our collision system. So we need a similar structure as the collision system struct, right? So what are we copying here? Obviously, we need to have a structure in the first place called the reaction system. Right now, the reaction system not going to have any state, but we might just go ahead and take that boilerplate. Well, oh, we're not using the allocator on the collision system. Oh yeah, we're not right now. Oops. Well, anyway, it's kind of boilerplate, so let's just go ahead and just use this boilerplate to have kind of a standard way we handle things for creating a new system. Even though we're not using the allocator yet, we'll just do things in the same way to be consistent. Okay. And we need an execute function, of course. We'll have an execute function on all our future systems like this. And pretty much inside of here, we're going to loop through all the entities and update update their state or force transitions when attacks occur. One thing to consider is we're going to have a hit event that's stored somewhere. The hit event should be stored in the that's something that's going to be stored in the reaction component probably. We could store it in the reaction system, but it's going to have to keep track of all the different entities. Now I am thinking about something. It's actually a little bit of a design choice, but in general, we would not expect to have a hit event be persistent between frames. Again, anything we store between frames could potentially have an effect down the line. So I think I would want to create transient data here, kind of like our collision systems scratch hitbox data, right? So in this case, what I'm thinking, which I've done in the past, is have just a hit event structure that's only available for that frame. What I'm thinking about, and something that I just want to point out is, again, because anything that could affect the future state of that could be applied later frames would have an effect on the results, right? Like what the state it becomes. That means it has to be stored in the rollback system once we get there, because for rollbacks to work, we have to store the entire game state. Anything that determines the next frame has to be stored. So anything we don't have to do that with, I want to avoid. Okay. So like the collision system, what I'm thinking actually is those hit events need to be cleared out each frame. So there's two things I'm thinking about we could be doing. We could force the reaction system hit events to be cleared out each frame. So within the reaction system itself, it has its own storage. Or we would have to do something like the component. If we stored it in the component, the reaction component, I'm less keen on that, because I want to be able to, in the future, I want to be able to copy all the components for rollback system store restore. And so I don't want to have like pieces of each reaction component not being something that's stored restored. Third option is to create these singleton component things. This idea, I think it comes from, I was watching Blizzard talk for Overwatch, which are just, they're outside of the normal components. They're just storage, right? We could have it outside the system. So I'm playing around with the different ideas. I might refactor in the future. Just think about the trade-offs here. So again, we could do something. We could make this kind of scratch memory. Sorry, like the scratch memory we have, and force it to be cleared each frame at the beginning of the execute. Well, it couldn't be so this is the tricky thing. We wouldn't clear out at the beginning of the execute. It would have to be the end of the execute, because we need to have other systems pass on that data. And actually, this is another bigger issue with architecture I'm thinking about. And again, I've done this in other projects. When we do our phases, when we're executing each part of our gameplay code, I want data that's just transient to be passed along from one system to the next. I don't know of a perfectly elegant way to do this. It often involves like globally accessible data, which is generally you want to avoid, but it ends up being the most simple way to implement these things. So let's say the collision system. So one thing we could do it is the collision system itself could have events, and then the reaction system could read those events. And at the beginning of each frame, the collision system clears out those events. That's not a terrible idea, actually. Or the reaction system is responsible for clearing out the events. Either way, I just want to avoid having persistent data that's reused through subsequent frames. Okay. So for now, let's just do that. Let's have the collision system. Or should we have a shared resource? Again, like a component that's outside. components that are not expected to be stored and restored. It is tricky. We also have to set up access to those components. Okay, let's not commit too much on this right now. We can always refactor. So what I'm thinking here is, our game state has these components, right, like this. So let's call these transient. Let's just call these transient events. So events that are only stored per frame. Yeah. So something like this. Hit events. Let's have hit events as something, and we'll have a limited size on these things. So for now, let's make it a array list, right? So let's make it an array list of some hit event structure, which we don't have yet. Well, let's put it here for now. And let's just have the entity ID for the thing that got hit. Wait, so we want an attacker ID. That's going to be useful. I think we can use size for that. And then it's called defender ID. Use size. Okay. This needs to be a struct, right? Okay. So there should always be a value for this, right? So we don't have to worry about sentinel values, because there's always going to be attacker, there's always going to be defender. Okay. So we'll make this hit event. And sorry. Then when we init, hit events. How do we do the standard array initialization stuff? Array list. Yeah, something like this. It's just a init with allocator. Okay, cool. That makes sense. Standard array list hit event dot init allocator. Okay. So before I forget, we need to make sure to let's see, hit events, and we need to clear out hit events each frame. That's important, just not forgetting about that. Okay. Sorry, I'm a little tired today. It's early in the morning as usual for me out here. Okay. We're at game state. Okay, so we initialize that. We also want to we don't want to allocate memory in real time, right? So let's go ahead and just reserve I want to reserve. How do we sit? How do we reserve? I forget what's the function for reserving. Resize. A init capacity, that's right. Init capacity. So init capacity, I think is the right one. That shows capacity to hold in idleness. Okay, so init capacity, we need the allocator. And again, I'm just doing artificial sizes for these things. We need to come back and really not use magic numbers for this stuff. That kind of work is quickly piling up. But the way we'll do it is hopefully we'll get exceptions thrown if we get too many, and then we can go back and fix it. I'm thinking maybe make it a configurable property in the future. I don't know. I mean the number of hit events. Okay. Oh, by the way, I have this caption thing set up going. Sometimes it stops working because it's not focused on. The window is not focused on for me, so I don't know how to deal with that. If any issue pops up there, just let me know. I'm trying to do my best here to get this all working right. So, yeah. Anyway, let's go move on. Where are we at? Okay, so we set this up. Let's just say at the beginning, for now, let's put everything's in the collision system. Or maybe not the collision system. It might be better to have the phase hit events be cleared out in the game simulation itself. It's always tricky to decide where to put these things. You know what? We're just going to put in the collision phase for now. So let's yeah, let's clear out all hit events. Clear. So game state.hit events. I'm going to shrink returning capacity. So hope this works. Yeah, 0. I'm just going to hopefully pray that works. Okay. And then when we have an event here, instead of just pressing debug, which we're going to do, we're going to set up the hit event. Yeah. So we're going to, is it append? Yeah. And we need to append a hit event. What's it? Game data dot hit event. And we need to say attacker. Oops. Dot attacker. Attacker ID is equal to. Hold on. We need to get the index of them. Let's say 0 for now, and then defender ID is going to equal to 0 for now. And then we need to get those IDs. So we have attacker index and defender index. Okay, so. And then we got defender index. Great. So we stored those entity IDs here. In the future, I might want to use more different IDs so it's safer and independent of the index used in the entity, but so we can actually search for those entities without using just the index into the array, right? That might be something I want to change in the future. But for now, we'll do this. So now we have the hit events being generated when these overlap things happen. So that should work. And let's just test that real quick. I'll just hit a debug point, right? What I'll do is add this here. We'll jump into the game real quick. Of course, I want to see if there's any errors or anything like that. Yeah, of course there's errors. Use undeclared game data. Oh, so I didn't include game data in here. Oh, it's not game data, it's game state. That's my bad. Wait. Sorry. It's in the game state. It's in the game state module. Sorry. What else is the error? Unused capture. Oh, really? 132. Oh, that's probably the problem. Yeah. All right. Let's just comment this out for now. Okay. The unused function. Okay. Let's do this for now. Okay. We'll come back and deal with all that. Habits of C, not even realizing it. Do you have anything playable yet? Oh yeah, hold on, Angry Bit Gamer. Let me just like link you to our GitHub page. Yeah, it is playable in a sense, right? It's still a work in progress. Zig because, well, first of all, I want to get away from C++ for future projects, especially these kind of like more educational stuff, streams and such, because I didn't want to explain C++. C++ has so many pitfalls in it, and it's a big pain to set up for everybody involved. And I just kind of, Zig had like a nice set of minimal features that I wanted out of programming language, like its focus on manual memory management, things like that, which is very important in game making. What's going on here? Did I not? Oh, what the heck? Oh. Oh. You're right. I should have done init capacity here. Oops. Yeah. But yeah, I looked at a few different languages. I looked at Odin. I looked at Nim in the past. I looked at a few different things. I didn't like Nim because it is the Python style syntax of using tabs to indicate blocks of code. Odin looked cool as well, and it's actually used in a real world product right now. I forgot the name of it for creating special effects. But I had already had some experience with Zig until I saw Odin, and also I just the Zig community seems very, very active. So I thought this is not going to be a language that's dropped by the maintainers, so I want to stick with it. It has a great, like everything, the cool thing about Zig is everything in the ecosystem is written in Zig. You don't have to use a third-party language to do things like builds and stuff. The build scripts themselves are actual Zig code. Compile time code generation is also Zig. It doesn't require a special template language or anything like that. What did I miss up? Oh, I need to do a try. Yeah, I need a try, right? Yeah. Also, yeah, it has like, it has focus on error handling. You can't just like allocate memory without handling errors involving error management. Sorry, memory management. Does it know what is the memory quality event? Oh, it doesn't, right? Is it because it's not public? Oh, it is. Oh, right. I'm just going to move this in here. Does that work? No. Can I do that like this? No, it doesn't work either. Okay, hold on a second. I need to do something. Oops. What I need to do is import not just game state, but So so I could just do this and it'll be fine. Should be fine anyway. Oh, I need to do a try here. Okay. Probably don't actually need this now. Learning memory management. Hold on, give me a second here. There's a lot of stuff out there. What did I not do? A try? Expect to type void. Hold on. Oh, it needs it. Okay. That's right. Well, there's. Yeah, this was right. This was right. This is going to throw an error, so this also needs to. This also needs to potentially throw an error. Okay. Books. There's game programming engines. It's a pretty decent book by one of the developers at Naughty Dog, I think. It's like, hold on. It has all kinds of information about game programming. I don't know if it's the best for memory management, but game engine, something like that. Architecture, yeah. This book, Game Engine Architecture by Jason Gregory. It's great. It has all kinds of information. So I'll just check it out. There's older editions as well, but yeah, so keep that in mind. You may want to get the most recent one because it does have information on like entity component systems and such like that. Yeah. Okay, we're going to have to change the way we handle this stuff a little bit because I don't have execute. No, execute is. Are we not calling try on execute here? Okay, hold on. Oh, we are. So what's the issue? Oh, because this doesn't throw an error. Duh. Okay. I thought. So we're going to have to try as well. Hopefully this throws an error. Yeah, it does. Okay, cool. I don't know of any other books top of my head. Okay. So we should get a breakpoint here when I hit attack. Yeah. Okay, cool. So when we step over, well, let's step into our game simulation. So we just updated the game. We executed the system. So we should be able to go over here and inspect this actually. So we should look at our hit events. Yeah. So there's only one item, right? This is great. We got the one hit event. And we got attacker 0, which is player 1, player 2 is defender. Okay, makes sense. Let's loop back around and see if our hit events are cleared out yet. It shouldn't be cleared out because we haven't gone through the collision system. And actually that attack is active for several frames. So, what? Oh, game data, val, characters, action maps. It's not game data, right? It should be self. Sorry. No, it should be game state. Let me clear out all this. Oops, no, okay, already. Okay. So again, this is going to be length 1 right here. Let's loop back around again. If we do a few frames, it should no longer be. Okay, it goes to length 0. If you remember, our attack is several frames long. So it's 4 frames. So let's just make it 2 frames. Restart our game. Go back here at a breakpoint. So we should only see it active for 2 frames, that hit event. The thing is, like, we're not going to support, well, sorry, attacks should only cause an event once. Right now it's going to cause an event each frame because we don't have support for that part. And we'll actually go ahead and write that down because I just thought of it or remembered it. So let's write down, make sure hit events are only generated for the frame they first occurred. Okay. Cool. We'll have to think how we're going to implement this a bit later. But for now, let's continue. I'll have a breakpoint there. What we need to do is go generate this hit event. Okay, we have that. So let's just go to our game simulation after they execute and look at our hit event struct. Sorry, we can see that items 1 and the data is this. Loop around again. Still active because, again, like I said, we haven't done that rule of like only applying the first hit. Loop around again. Well, actually, we haven't gone to the next frame yet. The breakpoints here is not exactly what I expect a lot of the time. I'm not sure why it seems to keep hitting the same thing multiple times. Yeah, so we can see it's 0 now. Anyway, so we have that set up. How are we doing on time? Oh, about 40 minutes in, so we've got a lot of progress at this point. So we have the hit event generation. What we need now is hit reaction. Actually, before we do that, I do actually kind of want to prevent hit events from being fired multiple times. So the way we're going to handle it for now, we're just going to add a property onto the character called attack hit. Once the attack has hit, it's not going to allow you to have that attack hit multiple times. In the future, we're going to show how we can have attacks that have multiple hits. But for now, the easiest way to do this is just add a new boolean to one of our components that stores whether attack hit or not. So let's go to our components real quick. We have the timeline reaction component, physics component, hit event. We have more components as well. It's in our action state. I thought we didn't make a component folder. We have a combat component, right? Let's put in our combat component. Where is that? I know I put that in another file. I thought I made a combat component. I haven't made combat component yet. Hold on. Oh, it's state machine component. That's right. We have a state machine component. So, how do we want to handle this? It's not perfect to put it in the reaction component. But we can move it out of there later. So, let's see. Attack has hit. It's a bool. It's going to be equal to false. Okay. We'll probably move this out somewhere else in the future. But for now, I'm going to do that to prevent attacks hitting multiple times. So in the collision system, the new rule we're going to have to add is we're not going to check characters whose attacks already hit. Okay. And we'll talk about in the future how we're going to handle multiple enemies being hit, things like that. We're going to have to add, like, is the last person that was hit by the same as the one that just hit you? Are they still in the same attack? We're going to have to add a bunch of rules about that. But we're not going to get that far right now. So we're at a new rule. Whoops. Actually, no. We're going to go through all the attackers. Yeah. So don't let an action hit more than once. So what we'll have to do here is we'll have to pull in the component, right? Yeah, we should have a list of the components, I think. Hold on. Oh yeah. So the way we're handling this now is game state dot reaction components attacker index dot attack has hit. Before I forget, I'm going to do this. I'm going to say we need to do two things, right? I was going to go ahead and just get the component here. So we'll just do this there. If this is the case, we'll just continue. Skip over this loop. We won't check this character against anything else anymore. So when this does occur, we need to update this, right? So we're going to set this to true. And actually, we'll need to reset this every time we do a state transition, right? So before we get there, before we forget any of this stuff, when we start a new attack, where's our state machine? I'm going to move this out of this folder probably. Anyway, thinking to myself there. So when we do a transition, yeah. So it needs something like that. We should have a context reaction component. We don't need this part. That'll be okay there. And that's going to eat false. Okay, so that should let us, it should only let attacks hit once, right? Hopefully I didn't forget something there. But we'll check that real quick. Okay, I didn't put in there. I thought I had added it there. Oh, not reaction components. Reaction component should be there. Oh no, it's named wrong. That's where okay, it's reaction component. I'm gonna refactor this stuff as well. I don't like that I've made it capitalized like that. Okay. So we should only see the event generate once. And you can see hitbox overlap happened once. If I attack again, does it hit? Cool, it does hit. Great. So that means our hit event should only exist for the one frame, which is amazing. What we do expect, so let's just test what we expect real quick. So we expect this to be hit, of course. And then next time we update the collision system, we're going to clear out this, right? So continue. And now the game state dot hit events should be clear to 0. Yes, it is. Great. That's what we want. Okay. So we have that set up. Okay, something we don't have set up yet is hit stun. We still need to do the hit stun. We still need to do the reaction. Let's just look at our planning document real quick. So we don't have the reaction yet. We haven't done a reaction system as well for handling all that kind of stuff. Reaction is set up. Wait, did we do? Yeah, we did a reaction system. Sorry, my brain is. We created the reaction system. We created the hit events. We've done this. We haven't done the transition yet. No hit stun support. None of this. None of this. I don't think we'll get to this today, but we did do this. So great. That is supported. Okay, so So we're going to implement our hit reaction. Do we do transition? Yeah. Yeah. Let's just move this up here because it's kind of like part of this. Okay, so we need to set up a transition when this stuff occurs. We'll do this in the reaction system. So the reaction system will handle the transition. And if you remember, going back to code architecture, reaction system is going to be at the very end here. So it's going to override any kind of action transitions that occur before then. Again, we're always talking about like this order of how things happen, and that ends up determining priority a lot of the time, especially in this very single-threaded kind of serialized execution that we have. These phased transitions. So, okay, so what we're going to have to do is we're going to have to loop through all the hit events. So for game state dot hit events, we're going to get a hit event. Okay. Okay, so what we'll have to do is we'll have to get, let's see, var defender is going to be game state dot game, is it game data dot int, what component? Oh, or is there components in here? Yeah, okay, they're in here. So let's say state machine component dot b. Oops. So we have to set, sorry. So, is it items? Oh no. So we need to do hit event dot defender ID. I think that's right. Yeah. It's gonna do defender state or something like that. It's easier that way. And one thing we have to do is like we have to set up the transition, right? I thought contact transition, yeah. We need a transition, and we need to do we need to set this up for reaction. So we haven't set up a reaction state yet, so that's going to happen there. Yo, Comic Man, what's up? Thanks for dropping by again. So we're going to have to assign the next state here. We're going to have to hold on, give me a second here. Something I also want to talk about. So our state machine gets updated before this, and that's actually what's handling the transitions. I'm probably going to have to remove. I need to be very careful about the staging here. So this is, if we're going to just do one transition in one place once per frame, I'm going to have to move the state machine to after this, which does mean there will be a time lag of one frame every time we transition to an action, right? So that's something we have to be very careful about. We'll just go ahead and do it, and then we'll look into the consequences afterwards. So I think that's kind of a nice learning component of this. Okay. So we're going to set up the transition. How do we do that elsewhere? Just to stay consistent with our other code. Probably should just make a function that handles this utility function. So we just do state machine. So we have to get, say, okay, well, it'll be something like this. Okay. Be state machine, combat state. So we haven't imported the state machine yet. So let me import that as well. We should have a reaction. Yeah, we should have a reaction set up already. Okay, that's set up. So that should work. We haven't initialized this reaction anywhere yet, though. We'll have to do that. So real quick, let's just initialize that somewhere. Oof. Yeah, we have to do this too for our reaction. So more boilerplate stuff. Reaction callbacks. Name it reaction. We'll have to create a reaction. So we need to create reaction combat data as well. We'll write that down after this. Oops. Okay. Reaction, reaction, reaction. Okay. Let's write down real quick in our planning documents so I don't forget. Oh, there we go. Okay. Just did this. Create reaction. Add reaction data to the character data file. Okay, I'll have to do that. That's another part of this work. So we also have to make sure this gets executed, right? Is it still complaining about something here? Yeah, we have to make sure this gets executed. The reaction system has to get initialized and executed, right? We haven't initialized it yet, have we? Or did we? Hold on. Or is it collision? Yeah, we'll have to import this here as well. So oops. Okay. Hold on. Okay. Let's do the boilerplate first for the reactant system. So we do that there. Import it here. Do we actually need that here? I thought we initialized it somewhere. Oh, we have. Sorry, I want to make sure it's like that. Okay. Yeah. So the boilerplate is gonna be like this. So we don't have it here yet. So cool. So we need to import it here as well. What is going on here? Just copy pasting going to end the file. There we go. Update that. Paste. Boilerplate all over the place. So we did that here. And so no, we didn't initialize it yet, did we? Give me a second here. Why didn't it? Oh. Hold on. I wonder why. Oh, that's why, because it had a dot there. Okay. Okay. So that's set up. That's set up to execute. Going back to our game simulation, we're gonna reaction system execute there. That's gonna happen again because of everything going on here. There's gonna be a 1 frame delay on the just to point out on the acting system actually updating it. Okay. The problem is attacks, other transitions might override anything that's executed within the state machine state unique function callbacks could override the reaction in this case. So I would need to move this to after here. We'll talk about the we'll talk about the consequences here in a second of that, but we'll get to that. Just give me a second. Okay, I think I forgot something. All the like the attack state, things like that. It's in our game state. Yeah, so we set up these attack callbacks. Yeah, so when you add the reaction callbacks, right? So reaction should point to the reaction callbacks, right? And then we'll copy paste this. Again, this boilerplate stuff. Okay, so that's set up. Now we need to have in our character data, we need a reaction. Right now, let's make it so the reaction the duration here is not going to really matter so much because things are going to be controlled by the hit stun. In the future, we'll talk about this stuff and how that's going to be handled. We're going to actually have a timeline that's going to control looped animations and parts of it's going to be more elaborate. So we're going to leave this as very long, so it's longer than our possible imaginable hit stun, effectively. There's going to be no attack boxes, so we're going to get rid of that. No vulnerable boxes for now. Once we add vulnerable boxes, you can do combos and things like that, which would be cool. So that's going to be there. Got that set up. So we have our reaction. We have what we expect there. So what pieces are we missing? Let's go back to planning. So we haven't actually got to the state code in. So we still need to handle hit stun. We need to handle the reaction state itself. We add this to the file, so that's done. Hit stun support is not in here yet. I'm just move this to the top so it's easier to follow. Again, this stuff's probably gonna go off to the future. I'm honestly just gonna take it and put it for next stream for hit stop. That's a whole other thing. Okay. Yeah, we need. Let's move this to the top. Okay, so we should have the transition done as well. We just did that, right? So this picks the transition. Let's just try to run it real quick to see what happens. See if we actually get any errors. We did get an error. Okay. 21. Oh. Oops. What? Maybe this is an error. Sometimes this doesn't update fast enough. 14. Collision system, not here. Okay. Oh, you're right. It is not the collision system. It is the reaction system. Unused function perimeter. Self. You're right, we didn't use self for now, so we don't have any state to actually look at. Statement. Oh yes, it's not under there. It's under the action states folder. Action states, not action state. Okay. Sorry. Yeah, no. I got it. Has no member called reaction. We don't have a reaction? Okay. I thought we had a reaction. Okay. Oh, we're out of the reaction to our enum there. No member name length. What are we doing here? Oh, right. Right. That is an array list. Being array list, it means we have to look at the items, not at the thing itself. So. Okay. Nothing really should happen here, but we didn't get as you saw, we didn't get any reaction from it. No transition occurred. Let's just see if we hit this code real quick. Oh, because I think we're making a copy here. Is this what's happening? Yeah, hold on real quick. That's the problem. I didn't. Okay. Up, and you can see we had attack started, hitboxes overlap. We end the standing state of the one entity. Reaction state occurs. Reaction starts, and then standing starts on the other entity. The reaction never ended, as you can see here, right? So that's what the hit stun's going to be for. So first thing we need to do, we got some time, right? It's 104. Okay, I'll work for a little bit longer. So let's just do the hit stun. We'll be done today, and return back to idle from hit stun. Okay. Let's see. And we'll talk about the nuance and stuff, all this stuff next stream. I just want to get the initial implementation laid down, and we're going to look at all the problems that get caused. Because part of what these streams are about are showing the common issues that occur, especially when you kind of take a naive approach to implementing this stuff. All the little subtle frame timing issues that pop up. But anyway, yeah, let's get to the hit stun. So what I want to do here is look at our, what was it, our components. So we're going to have like a hit, well, let's going to say, so on a reaction component, we have this. Our hit event, we also need we need hit stun. Okay. We need that as well. And when the hit occurs, we're going to take properties from the action. But for now, well, actually we could, I think what we'll want to do is actually point to his hit properties, right? We don't have a hit property struct yet, so we're probably going to replace this with a pointer to that data or make a copy of it. Actually, no, I think it's better. We're going to make a copy, and that's going to allow us to have overrides depending on the state of the game world, right? There might be situations where hit stun is reduced, things like that on hit. So, but for now, we'll just have it just hit stun, and let's go to our collision system. And we'll, when this happens, we need to assign the hit stun. Let's just say it's 25 for now. This is 25. Okay. So that occurs. Whoops. So the hit stun set here, and in the reaction system, we need to assign the hit stun. Yeah. It's not here, so we need to get the reaction component, right? So reaction components, and we're just going to say stun equals hit event dot hit stun. Okay. And we're going to count down this each frame. So now we need some code for counting down hit stun. So the first thing we're actually going to do before handling hit events is to count down hit stun. Again, order matters here. Let's just think about it first. What if there's a one frame hit stun? Well, you got to hit this frame. And we want to make sure you don't transition until one frame later. These kind of edge issues end up being tricky to think about. I like to think about it as what does a player see? If a move have one frame hit stun, you need at least, you want to only go through visibly seeing one frame of hit stun, right? So if you transition this frame, this is why this stuff matters. Let's assume you're going to transition this frame. We're going to make it immediate. Then what's drawn on the screen, this frame will be, there will be in hit stun. And then the frame after that, they need to transition back to idle. So just keep that in mind as we do this. So I want to loop over all the reaction components, and check for things where hits. And we need to iterate. Sorry, we need to decrement. We need to decrement hit stun. We have this right. One. And then once it reaches 0, actually, we first need to check to see if it's greater than 0. So we don't transition entities that are not in hit stun. Oops. Then we'll assign it to transition to so technically this should never be less than 0, but this weird thing inside of me always wants to leave this here just in case. The intent should be clear, right? Okay. So we'll do this and say go back to for now. Let's go back to standing. In the future, we're going to have a transition function that takes care of this instead of just going to standing. I just want that to be clear, so you can go into any kind of thing, but any kind of attack or whatever. Like as you're coming out of hit stun, you're going to need to be able to go immediately into attack. You shouldn't have to go through standing and incur this 1 frame penalty. So that's going to be replaced. Just to point out for now. So that's something coming up. So anyway, yeah, we transition back to idle. In this case, standing animation only once hit stun goes to 0. So what this means is the order is we add the hit stun on 1 frame. The player sees it on screen because the rendition happens at the end of the frame. Next loop we go around, next time this execute is called, we decrement the hit stun. Once it's 0, we transition back to idle. So that frame player sees a standing action. That means 1 frame hit stun works as we intended. 2 would be the same way, right? So this applies 2. Next frame we see stun, comes around, 2 gets decremented. It's only 1, so it's not less than 0. Player sees hit stun, the reaction, for 2 frames on the second frame. Loops around again. That 1 becomes 0 after this decrement, and you go back to standing. And so on the 3rd frame, you do see standing. Okay, so that works as intended. Now, this only works that way if we have the actual transition occur after the this is called, right? And right now the problem is, I'll show you. Right now the problem is in our game simulation, we have this. We have the action system is updated before our collision system and our reaction system. Now, one solution is to separate that transition code from the action system into a second phase to put it afterwards. If we look at what we did in our architecture document, we have the reaction system at the very end, but we never put like the intent here originally was that it was going to handle the transitions itself. So the action system handles the transitions, this handles transitions, which we can do. So this is something to keep in mind, something we might refactor in the future, right? So let's just jump into our, because I don't like to have duplicate functionality, things that could be handled in one phase, but it may be unavoidable in this case. So let's just go to our game simulation again, right? Where's that? Yeah, it's actually handled in the update state machine code. This is outside the normal state machine. We could have moved things into the state machine itself as well, right? We could have moved this reaction stuff as special exceptions into the state machine. But I intentionally wanted the reaction system to be something outside of it. So the state machine is for updating normal action flows of everything, and the reaction system is kind of an override into that. So what we'll have to do is go to our update state machine function. Again, we might move this functionality out, but so for now we're just going to copy paste this stuff into our reaction system. Again, not ideal for now, but so the final thing we'll do is handle the transitions. And we don't need all this code. And also we need a loop through, sorry. Yeah, so what do we need? Yeah, we need to do all this stuff. So we can move this into a utility function if we really wanted to. Which we probably should for now, at least. But I'll just make sure we have all the things we need here. Okay. Did we get the state machine here? Yeah, so let's just extract this into its own thing. I think that's probably the best way to go about it. So we'll extract that out into a new utility function. We don't have the parameters yet for it. So we need a context. The context is a pointer to combat state context. Okay. So we have that. Oops. What else do we need? We need, well, we need a state machine. Honestly, I probably want to move this out of the state machine itself, I just realized. Anyway, we need how do I want to do this? Let's just make the state machine first. Honestly, I might store reference to the context in the state machine to the context itself, now I'm thinking about it. Anyway. What else do we need? We need the character data, we need the action map. It's a lot of stuff we need to pass in. We need the next state. Well, we don't need the next state. It comes in the context. Great. Do we need the state, though? The state comes from... Well, anywho, we're just going to assume we need to pass in all this stuff because it's literally pretty much that's the case. We'll just say state machine for now. For here, context, character data, it needs to return void for now. Is there a self in here? Get rid of all the selves. Replace that with state machine. So yeah, we're storing this in the state machine, the state next state. I want that. It's probably gonna be the state machine context. I'm gonna move, or yeah, I want to think about doing this in the future because I want everything to come be in components and not into its own little thing. So I don't want data to be spread out over the place. So I really want to refactor that stuff. This is a good time to think about that. Okay. So this should be all taken care of there. Is there anything we're missing? We are missing state. So state is current state, actually. Honestly, we can pull that from here. It was convenient that we had it here. Do we pass it in? Do we pull it in? Do we pass it in? Do we pull it in? You know, just for convenience sake, I'm gonna just go ahead and do that here. I'm gonna pull it in again, even though technically you could pass it in. Just so we don't have to, so we have less perimeters here. Actually, this could throw an error, right? So I think technically, it's interesting. We didn't get an error about this before. Oh no, I think it's fine because we just kind of saves capture thing. Okay. What is the problem here? So we should be able to like pull this all out. Oops. Yeah, we should be able to do this all out. So pass in self, context, and all the other parameters here, right? Character data, action map. Okay. Character data, action map. Oops. Is it really lowercase? We did make it lowercase. That's annoying. Okay, I'll fix that in the future. And then we'll just pull this out. Cool. So that should be fine and dandy, hopefully. Hopefully that didn't break anything. I obviously want to test this here in a second. Yeah. Okay. Going back to the reaction system, I'm gonna just pull this out. I don't want to copy paste this stuff. So we'll handle transitions here in a second. And of course we get some errors about things. 26 hit event, undefined, undeclared. Where did that come from? Oh. Oops. Oh, it shouldn't be if, it should be for. Okay. Missing type. Oh, yeah. Okay. Hold on a second there. Okay. Starting to fade out here. Hopefully we can make it. $54 was the error. What is the problem? Expected. heck? This is... Oh, what am I doing here? It's a function, so it should be... My brain. Okay. 135 in the state machine, 135. What did we do? Expected test compile. That's an interesting error. It definitely is. What did I mess up with the syntax? Did I mess up curly braces somewhere? Yeah, I messed something up here. I did, I guess. Let's look at the diff real quick because sometimes it's easier to find error if you do that. Okay. So we added this function, right? Pub fn, that's correct, right? Yeah, we added this function. We just deleted all we did was delete all this stuff. Wait. Oh, we deleted a curly brace, didn't we? Okay. I think that's the problem. We deleted a curly brace. Yeah, there we go. That's what I thought. Use undeclared self. I thought I got all those. That should have been state machine. Okay. That's the most important one. Oh, again, missed that one too. Whatever did get here. No member name hit stun instruct event. There's no hit stun? I thought I added it. What? Hit stun. Oh, wait. Oh, we have 2 hit events. Wait, what? Hold on. Give me a second. What the heck? Whoa, what did I do? It says instruct game state hit event. Hold on. Did I make 2 hit events without realizing it? I did. When did I do that? So this other hit event, I must have made before. Let's look at the components. Yeah, this is the old one. I'm not using this. Okay, I'm gonna get rid of this. That should be not there. Okay. Oh. Oh, we did store this in hit component before, right? Oh, we had a hit component. Do we even use this? This is something we had done before, but I just didn't use? Give me a second here. Yeah, we're not using that anywhere, so that's going away because we never used it. I might have had a different design intent at that time, but I've now forgotten it. Oh, it's a const. Oops. Okay, reaction system. 22. This is a const. Is this how we do it again? I forget. Hold on. Expected I32 font use size. I made this. Did I mess up? Did I mess up here? Did I make it? Yeah, I did make it use size. Okay. Oops. My bad. Okay, so that works. So I'm just doing attacks here, and you can see that after a set amount of time, it returns back to standing state. So we go through attack start, hitbox overlap, standing in, reaction starts, standing on start. We never do on end, do we? On end is never called. Why is that? So standing on end and start. Do we mess that up here? No, we have shared functionality, right, for the state machine. So on end should be called no matter what. Well, if there is on end. So what do we mess up there? So our reaction has a name, an update on start. Oh, we did not give it an on end. That's true. Oh, okay. Didn't realize that. On end plus common states dot reaction dot on end, and we need the same thing for the attack. I think on end equal to common states dot attack dot on end. Okay, so we should get. Let's close that out. This is about pretty much what we're gonna do for today. Nothing exciting to see visually, but we can see things are working as intended. Okay, so when I hit, what occurs? I walk forward, go back to standing ends, walk forward, then attack occurs on start, overlap occurs, standing ends, reaction starts, attack ends, and standing goes back. That's and then reaction finally ends, and then standing goes back to on start. Yeah. Attack on start, hitbox overlap, standing ends, reaction starts, attacks ends, standing starts, reaction ends, standing starts. Okay, that's exactly what we needed to do. It's working as intended. Awesome. Well, I hope that was informative for anybody. We will be working more on this next time. I think, what do we have in our planning list? Let's go through here and see what we checked. So we had a hit stun support, we had a reaction state, return to idle when stun is over. This is something I'm just going to put off for now because it shouldn't affect us at all, but I'm just going to put it off for the future just in case. So we did everything on our list here, and even the new stuff we added. So next time, what I want to handle is hit stop and hit stun. Sorry, hit stop. That's gonna be another interesting thing. Hit stop is when the characters pause for a brief moment before continuing their animation, or even their physics. So things like physics won't be updated during hit stop. Animation updates won't be handled during hit stop, and eventually we'll add effects on top of everything that will play starting during hit stop. But that's pretty much it for today. Thank you all for dropping by again, as always. If there's any questions, go ahead and ask. Otherwise, I'll be starting I'm gonna start shutting things down. Again, I appreciate everybody who's taking the time to stop by and chat. I think we made a lot of progress today, and hopefully make a lot more next time. Okay. Well, I'll post up the VOD for this as possible for people who got here late or maybe have missed it. Anyway, y'all, see y'all soon. Hope y'all get a good night or enjoy the rest of your day. Until then, see you next time. Goodbye.